Gonna do a classic proof today. Gonna show you that the sine of 10 degrees is irrational. But first we're gonna need some preliminaries. For example, I to the first is I, and I squared is -1, and if you square that last line, you get I to the fourth is 1, and if you multiply the second line by I, you get I cubed equals -I. So we're going to use that and a couple of other facts. We want to figure out what the formula for cosine of 3 theta is and the formula for the sine of 3 theta. Of course, we can think of 3 theta as theta plus 2 theta, use their cosine of 2 angle formulas, and then that would be in terms of cosine of 2 theta as well as the sine of 2 theta, and we know the formula for that. Same thing with the sine of 3 theta. We can think of it as the sine of theta plus 2 theta and use the sum of angle formula for sine, and that will have expressions involving sine theta and cosine theta, which is fine. But it'll also have terms and factors involving sine of 2 theta as well as cosine of 2 theta. And then we've used the double angle formulas for that. There's one way of getting a formula for the sine of 3 theta and the cosine of 3 theta. But here's a much better way of doing this. We know that the cosine of theta plus I times the sine of theta cubed using De Morgan's law, this is the same as, well, De Morgan's law says you can bring the power down and multiply it by the angle. This is the cosine of 3 theta plus I times the sine of 3 theta. So the plan is the left side we're going to multiply out, and then we'll equate the real part to cosine of 3 theta and the imaginary part to sine of 3 theta. Now what you need to recall is that a plus b cubed, well, you can think of it like this: a cubed, a squared, a to the first, a to the 0, b to the 0, b to the first, b to the second, b to the third, and you have coefficients 1, 3, 3, 1, all plus. And of course, b to the 0 is 1, and a to the 0 is 1, and 1 times b cubed is just b cubed, and 1 times a cubed is just a cubed, and b to the first we can just leave as b, and a to the first we can leave as a. Okay, so there it is. Now, what does this have to do with the line above? Well, a is cosine of theta plus b is I sine theta. So what we have is cosine of theta plus I sine of theta, all cubed. On one hand, so I'm going to call this a and that b. It's a cubed plus 3 times a squared times b plus 3 times a times b squared plus b to the third. And the first term is just cosine cube theta plus 3 cosine square theta times I, which is I, and I put that in front, times sine theta plus 3 cosine theta times I squared times sine theta squared. Well, I squared is -1. So that just makes this plus a negative sine square theta. And I cubed is negative I. So it's negative I sine cube theta. Now let's just find all the reals and all the imaginary parts. If it has no I, it's the real part. Cosine cube theta minus 3 cosine theta sine square theta. Those are the real parts, plus the imaginary part is what has an I. I factor out the I, so it's 3 cosine squared theta sine theta minus sine cube theta. And now we know two things. This is equal to the last row, and it equals this. That is, this must be cosine of 3 theta, and this here is sine of 3 theta. So let's just write that down. The cosine of 3 theta is equal to this. In fact, I don't think we're going to need this formula, but it came for free. I knocked out both triple angle formulas in one shot. The sine of 3 theta is equal to 3 cosine theta sine theta minus sine cube theta. Okay. Now, I just want to clean up that last one. I don't want it to have cosines in it. So right now, we know that the sine of 3 theta is 3 cosine square theta times another sine theta minus sine cube theta. But cosine squared is the same as 1 minus sine square theta. So we get 3 sine theta times 1 minus sine square theta. That's the cosine squared minus the rest. Distributing this times 1, of course, is just this, minus 3 sine cube theta. Minus another sine cube theta. So in all, we have 3 sine theta take away 4 sine cube theta. So in the bottom right, I'm going to replace sine 3 theta with that. It's 3 sine theta minus 4 sine cube theta. Okay, wonderful. So we know that the sine of 30 degrees is equal to 1/2. So let me write that. The sine of 30 degrees is equal to 1/2. Why do I want to write theta? It's beyond me. The sine of 30 degrees is 1/2. And in sine of 3 theta, let theta be 10 degrees. Okay? So using this formula down here, we know that the sine of 3 theta is equal to 3 sine theta minus 4 sine cubed theta. Okay, and again, let theta be 10 degrees. So this is 1/2. Now, we know that the sine of 10 degrees, this is a key point. The sine of 10 degrees is a solution. Okay? Because this is the same as sine of 3 theta, but the sine of 3 theta always equals this. Okay, it always equals this. Now, if I let theta be 10 degrees, then theta equals 10 degrees is a solution. Then theta equals 10 degrees is a solution. Because if I plug 10 in here, and here, and here, the equality holds. It's just that the sine of 30 degrees is a half. So now, we let x equal to the sine of theta. So I go 1/2 is equal to 3x minus 4x cubed. Well, in here, we have that sine of 10 degrees is a solution. Okay. So we know sine of 10 degrees is a solution. And this is where it all comes together. Let's see if this cubic has any real solution. Let me rephrase that. If it has any rational solutions. First, I'll multiply both sides by 2. Multiply both sides by 2. And I get that 1 is equal to 6x minus 8x cubed, or bringing everything to the left side, 8x cubed minus 6x plus 1 equals 0. Okay. Now I don't need the bottom formulas anymore. I do need the space. Okay. Now, by the rational root theorem from pre-calc, we know that numbers that go into 1, integers that go into 1, namely plus minus 1, divided by numbers that go into 8, which are 1, 2, 4, and 8, this tells us what the possible rational roots are. Possible rational roots are plus minus 1, plus minus a half, plus minus a quarter, and finally plus minus 1/8. So I'm going to write them up here. You have plus minus 1, plus minus a quarter, plus minus a half, and plus minus an 8. I didn't mean to change the order. And we want to see which one is going to work. Now, let me rewrite this without having circles around it. And we're going to talk about how this is partly an odd function. In here, if I plug in 2, if I got 7, then when I plug in negative 2, I would get negative 7. If I plug in 3 and I get 21 out, if I plug in negative 3, I'll get negative 21. Just for completeness, if I plug in 5 and I get negative 7, then when I plug in negative 5, I'll get positive 7. So, I want this to either be plus or minus 1. I really want it to be minus 1. Because then when I add 1, I'll get 0. But you know what? If I plug in 1/2 and out comes 1, I'll go, okay, I found the root. The root would be negative 1/2, because negative 1/2 would give me negative 1. This is an odd function. So that kind of makes life easier. I don't have to plug in all 8 numbers. Well, when I plug in 1, I get 8 minus 6, which is 2. And 2 plus 1 isn't 0, and negative 2 plus 1 is not 0, so that didn't work. Let me plug in 1/4. 8 times a quarter cubed minus 6 times a quarter. Well, a quarter cubed is 64. 8 over 64 is 1/8. And now we're taking away 6/4 or 3/2. I mean, this is 1/8 minus quadruple multiplied by 4 top and bottom. You get negative 11/8. Plus or minus that is not negative 1. Again, we want this to be negative 1. So plus minus 1 didn't work. Plus minus a quarter didn't work. Let's try 1/2. 8 times a half cube minus 6 times a half. Well, a half cubed is 1/8. 8 times an eighth is 1. Take away 1.5. Sorry, take away 3. 6, half for 6 is 3. 1 minus 3 is negative 2. Plus minus 2 don't work. Because when I add 1, I don't get 0. Where did the plus 2 come from? Well, if I plugged in negative 1/2, I would get negative 1 plus 3, or positive 2. But when you add 1, you're not going to get 0. So half didn't work. Let's try 1/8. Let's try 1/8. So basically, you have 8 times 1/8 times 1/8 times 1/8, and one of their eighths cancel out. We have 1 over 64 minus 6 over 8. I'll multiply top and bottom by 8. I have 1 minus 48 over 64, which is negative 47 over 64. And that's not negative 1. And if I plug in negative 1/8, I'll get plus 47 over 64. And when you add that last 1, you're not getting 0. We desperately wanted this to be negative 1 to find a rational root. But it turns out, so let me rewrite this. So the possible rational roots are plus minus 1, plus minus a half, plus minus a quarter, and plus minus 1/8. None work. So 8/8 cubed minus 6x plus 1 have no rational roots. But the sine of 10 degrees is a root. So the sine of 10 degrees, that's the perfect place to run out of, or the worst place to run out of space. So the sine of 10 degrees is irrational, because it can't be rational. So the sine of 10 degrees is rational. And that's what I wanted to prove. I came up with an equation, a cubic equation it turned out, that has sine of 10 degrees as one of its roots. However, we were able to show that this cubic equation had no rational roots. Therefore, the sine of 10 degrees is rational. like math like this, keep watching my channel. Please subscribe. That would be greatly appreciated. Tell your friends about it. Most of all, have a great day. Thank you.